Okay, this is video one for the quiz 5.4, which is over type 1 and type 2 errors. So our question is there a difference in mean systolic blood pressure before and after taking the drug losartan? Raw data for sample, and by the way, this is not supposed to say that is incorrect. I've retyped that. So is there a decrease? So we want to know, is there a decrease in the systolic blood pressure um, before and after taking the drug? Raw data for the sample of 8 participants is provided below. So when I look at this, I have a before and after situation, and each patient's data is paired. So this is going to be a paired test. And the reason that's important because the first thing they asked me to do is describe a type 1 error in the context of the problem. And when we're answering these types of problems, we have to sit there and define our null and alternative, and then we have to define our parameter. And so consequently, we need to know what type of test we're running. And this looks like it's going to be a paired t-test. So with that being the case, we're going to say mu d equals 0, and mu d is greater than 0. Now, here's how I came up with that. We have a before minus after situation. So I chose a before blood pressure, and I just chose one. I said, you know what? They have a blood pressure of 120. That was before. And they said they wanted it to decrease. So afterwards, it needs to be less. So if it's less, this is 100. 120 is greater than 0. So I need a greater than sign there. Okay, so I need a greater than sign there. So let mu d equal the true population mean and difference in systolic blood pressure before minus after. Remember, you always have to state the part on how you're defining it. Then the next thing is when we're doing a problem on type 1 error is we need to define what type 1 error is in general terms. In other words, show them that we know the basic definition. The basic definition is a type 1 error is rejecting the null when it's true, right? Rejecting the null when it's in fact true. So that would be an error because we rejected the truth. Then we need to put it in context. In this problem, a type 1 error is rejecting the null that the mean difference is 0 and believing that there is a reduction when in fact it has not decreased. In other words, we rejected that it was 0. We believe that there's a decrease, but it hasn't. All right, but it hasn't. The next thing we always need to do is give the consequence. I separated it out in this. It just said, because it said here in the next problem, part 2, it says, what's the consequence? So I didn't feel the need to write it twice, but you always need to give the consequence. The consequence is that patients and doctors believe that the mean systolic blood pressure is being lowered by the medication when in fact it isn't working, and this could result in catastrophic health issues. Obviously, if my blood pressure medicine is not working, I could have a stroke, a heart attack, or some other issue. So consequently, very, very serious. Type 1. A type 2 error. Describe a type 2 error in the context of this problem. Once again, when we're doing a type 2 error, we're going to define what a type 2 error is. All right. So by definition, general definition, a type 2 error is failing to reject a null when in fact it's false. Well, that's the definitional purposes, but we need to go on and then put this into context. Because this will get you no credit by itself, but it lets the reader and the grader know that you know what you're talking about. So in this problem, a type 2 error is failing to reject a null that the mean difference before minus after is 0, when in fact there has been a reduction in blood pressure, systolic pressure. So basically we failed to reject the null. And by the way, I should always have stated my null and my alternative. Once I had them up there, I didn't redo them, but technically I should have mu d equals 0, and the alternative, mu d is greater than 0, and I need to give define the parameter. But I've done it previously, so I'm not going to do it again. So we failed to reject this when in fact it was false. So We continued believing this when there actually was a reduction in systolic pressure. In the context of this problem, what are the consequences? Because remember, we always have to have the consequences. And the consequences is that patients and doctors believe that the medication does not lower blood pressure and choose not to use a medicine that is effective for treating blood pressure. So in other words, they're missing out on a blood pressure medicine that works because they believe it isn't working. So it turns out if we're doing a type 2 error, we failed to reject the null. The null was false, and that's a type 2 error. All right, I'm going to do number 5 and 6 on this, and this will be the end of the video when we get to 5 and 6, and we'll start the next video on the next problem. All right, so number 5, run a hypothesis test at an alpha level equal to 0.01 significance level to determine whether or not there's a difference in the mean systolic pressure before minus after. You may assume that all the conditions have been met. So once again, I need to write my null and alternative, and I want to go back over this. Remember, it was a before minus after. They were looking for a decrease. So if I have a before blood pressure of 140 and afterwards it's 120, this is a greater than symbol. This actually represents my decrease. It decreased from 140 to 120, so mu d is less than 0. Once again, we always need to define the parameter. Let mu d equal the true population mean difference in systolic blood pressure before minus after. All right, and I cannot stress how important it is that you tell me which way you subtracted. They said we may assume all conditions have been met. That's great. So conditions have been met. That's a given. We can check it off. We don't even have to do anything other than say that they were given. So the next thing we need to do is we need to write out our formula. Well, in this case, we're just working with a t equals x bar minus mu standard deviation divided by the square root of n. Plugging in, well, to do that, I need to go back to my original problem. To go back to my original problem, and I'm going to have to go back and enter this data. So, stat edit. So I go to stat edit, I enter the data in L1 and L2, but I don't have my difference yet. So I need to go to the top of L3 and go second 1 minus second 2. So L1 minus 2, so this gives me my differences. Now I need to calculate my X bar, I need to calculate the standard deviation. So I'm gonna go stat calc, one variable statistics. My list is not in L1, my list is in L3 because that's where my data is, the data of the difference. And I end up with a mean of 8.75 and a standard deviation of the sample of 6.9023. All right, so I'm going to use those values and plug them in. And I have 8.75 minus 6.902 divided by the square root of 8. So how do I run my test? I'm going to go to stat, test, and I want a t-test. And I have data this time. My mean, which is my null hypothesis, is 0. My list is in L3, so second followed by the number 3. And then I need to make sure that I've chosen a greater than because that's the way my alternative hypothesis is expressed. And I end up getting a t-statistic of 3.5855. And we have a probability of 0.0044. So I have a very, very small p-value. And if I take a p-value of 0.004, and they gave us an alpha of 1, so 0.004 is less than 0.01. And because my p-value is less than alpha, we're going to reject the null. So then we need to state our conclusion. Our p-value is 0.0044. We reject the null. There is sufficient evidence that alpha equal 0.01 to suggest that the true population mean difference in systolic blood pressure before minus after is less than 0. simplified. Okay, always give a simplified. Hey, the medicine lowers blood pressure. It actually works. Or the medicine more specifically lowers systolic blood pressure. The last thing is based on our results, what type of error may have been committed. So what did we do? Well, in this case, we rejected. So since we rejected, the only type of error that could have been committed is a type 1 error. Doesn't mean we did commit a type 1 error. This medicine really may work. We may have done the right thing, say it lowers blood pressure. But if we did make an error, we know we didn't make a type 2. Because we rejected, we could have only committed a type 1. All right, so this will be the end of our first video.